Hello, and welcome to today's lesson on probability. We're going to be covering topics under the standard 3.1c, and we're going to be covering questions in the study island topic probability. So if you're working on any of those things, this is where you want to be. Some of today's questions are some of my favorites. I just really enjoy probability and figuring out how likely something is to happen or not. So I hope that you enjoy it too. And as we're working through these problems, don't forget our study tips. You can pause at the beginning of an example and see if you can figure out the probability, and then work through the problem with me and see how well that you did, so you can get a gauge at how much more practice you need. As you're taking notes, you can pause the video and then rewind and fast forward if you need to, so that you can get caught up with your notes. And then you can continue with us. So I'm excited that you're here, and we're going to take a look at some notes and then do some examples.
All right, so first we have the way to calculate probability, or the definition of it, and that's the number of outcomes making up the event divided by the number of possible outcomes. And so sometimes you're asked to find the probability of a compound event. And a compound event is when two or more independent events are considered together. And so what makes an event independent, so that you can calculate that? And events are independent if the outcome of one event has no effect on the outcome of the other event. So if you flip a coin and get tails, and you flip that coin again, what you get the second time isn't dependent on what you got the first time. So those are independent events. So if we want to calculate the probability of an independent event, that consisting of two independent events, to calculate the probability of a compound event, you're going to multiply the probability of the first event by the probability of the second event. So that's this written out as a formula. So there's basically two formulas and some definitions you need to know: the probability of a single event and the probability of a compound event. This first example, we have an urn contains 7 brown marbles and 3 green marbles. 2 marbles are drawn from the urn with replacement. So with replacement means I pick one marble out, I put it back, and I take another marble out. What is the probability of drawing a brown marble on the first draw and a brown marble on the second draw? So this is what's in the urn. And so I have 7 brown and 3 green. So that means I have 10 marbles total. So the probability of picking a brown marble in the first draw, I have 7 brown marbles out of 10 total marbles. Okay, I put that marble back in, so I still have 10 marbles in my urn for the second draw. There's still 7 brown marbles in there and 10 total. So to calculate the probability of that, I'm going to multiply. So when I multiply fractions, you multiply the top, so 7 times 7 is 49, and multiply bottoms, 10 times 10 is 100. So 49 over 100, that doesn't reduce, so my answer here is B. This next example says 3 6-sided dice are rolled. What is the probability that all the dice are showing a 1? So this is the 6 sides to one dice. So you have one side of those 6 sides shows a 1. So the probability that the first die rolls a 1 is 1 out of 6, because there's 1 way to get a 1 out of 6. And then the same for that second die. It's a 1 out of 6 that you roll a 1. And then the third die, it's a 1 out of 6 that you roll a 1 there too. So then you just have those, multiply those to calculate the probability of this compound event. 1 times 1 times 1 on the top is 1. And then 6 times 6 times 6 on the bottom is 216. I can't reduce that fraction at all, so this is going to be my answer, Letter B, 1 over 216. All right, this example says, Pablo throws a paintball at a target his uncle made for him. The target is a square board with a circle with a 9-inch radius drawn on it, as shown below. Pablo is able to hit the board every time, but his hits are entirely random. What is the approximate probability that his next shot that hits the target will hit outside the circle? So it wants to know the probability of hitting this area. So to find that, we want the area outside of the circle over the total area. That's what we need for our probability. Now, the problem with that is this is an odd shape. We don't have an area formula for that shape. But what we can do is find the area of the square, find the area of the circle, and then subtract them, and we'll be left over with those odd shapes. So our first step is going to be to find the area of a square. We need to know this area, the length of both sides to do that. So we know the radius of the circle is 9 inches. So to go all the way across is going to be 18 inches. So that means this side is also 18 inches if we use our square and circle properties. And all sides of a square are the same, so both sides are going to be 18. Now, you can take 18 times 18 to find the area, or some people do 18 squared to find the area of a square. It's the same problem. You're going to get the same answer. And 18 times 18 is 324. So that's also going to be our total area. The total part that he can hit is 324 inches squared. All right, so now we got to find the area of a circle, which they give us that area formula here. So that's going to be pi times radius squared, and we know our radius is 9 inches, so it's going to be 9 squared. Well, 9 squared is 81, so it's going to be pi times 81. And you can use the pi button on your calculator or 3.14. And when you multiply those two numbers, it's going to be 254.34, or 34 hundredths. And so that's the area of the circle. But we need the area outside of the circle. So like I said, we're going to have to subtract 324 minus 254.34. And when we do that, we get an answer of 69.66, or 69 66 hundredths. So that's the number that goes up here. And because there are decimals here, we can't really leave, it's not proper form, standard the way of doing it, to leave that as a fraction. So we're actually going to treat that fraction bar as a division board. And 69.66 divided by 324 is 0.215. And that means our answer is D. So this example says, a box contains 2 red pens, 5 blue pens, and 8 green pens. 2 pens are drawn out of the box without replacement. What is the probability of drawing a green pen on the first draw and the same color pen on the second draw? So without replacement means that I take it out and it stays out. So the number of pens in the box is going to be less the second time around. So the first time around, if I count up all of my pens, I have 2 plus 5 plus 8. I have 15 total pens. And so it says, what is the probability of drawing a green pen on the first draw? So I have 8 green pens in that box. So there are 8 times I have a likelihood of drawing a green pen out of the 15. Now the second time, I don't put that pen back. So now there's 14 pens in that box. And it wants to know what's the probability of drawing that same green color Well, I already took one green one out, so I only have 7 left. So I'm going to multiply those two together to get my compound probability. 8 times 7 is 56, and 15 times 14 is 210. And if you have a scientific calculator, you can use that. Certain ones will simplify that fraction for you. And if you have that, you can use it. But if not, you can divide both of these by 14, and it simplifies to 4 over 15, which is the same as letter C. So that's my probability. I have a 4 out of 15 chance to draw 2 green pens without replacement. So this example says the following balls are placed in an urn: 4 red, 3 yellow, 6 blue, and 5 green. 1 ball is randomly drawn from the urn. What is the probability that the ball is either yellow or green? So first, I have I have to find my total number of balls. I have 4 plus 3 plus 6 plus 5. So I have 18 total balls in the urn. Now, how many of those are either green or yellow? Well, I have 3 yellow and 5 green. So that means I have 8 that are either yellow or green. So then that's my probability, but I can reduce that. So I can divide both of those numbers by 2, and that gives me 4 over 9. So I have a 4 out of 9 chance of drawing either a yellow or green ball, and that means my answer is A. This example says, at Southwest High School, there is a vending machine on the 2nd floor that is broken. So the students never know what kind of drink they will receive. Well, that would be kind of a silly situation. Of the first 43 students to use the vending machine, 12 received lemon-lime drinks and 19 received cola drinks. Samantha purchases a drink from the vending machine. Based on this information, what is the probability that her drink is neither lemon, lime, nor cola? Well, our total number of instances here is 43. So that's going to be my number on the bottom. Now, we know that 12 of those were lemon lime and 19 of those were cola. So we went neither of those. So we're going to want to subtract those numbers off of 43. And when I subtract those two numbers from 43, I'm left with 12. And so that 12 is what goes up here. And I can't reduce that fraction, so that just leaves letter A to be my choice, my answer. So that means I have a 12 out of 43 chance of getting neither lemon lime or cola. This next example says, an experiment consists of rolling 2 fair die and adding the dots on the 2 sides facing up. What is the probability that the sum of the dots is divisible by 4? So we have this chart that shows us all of the sums. So here, if I roll 2 1s, that is going to add to 2. Here, if I add 3 and 2, if I roll a 3 and a 2, that adds to 5. So this is all of the possible sums I could possibly get by rolling 2 die. And that's going to come in handy because I can go ahead and circle all of the ones that are divisible by 4. So 4 is divisible by 4, 8 is divisible by 4, and 12 is divisible by 4. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 different combinations of dice I could get to have a sum divisible by 4. And so how many total different ways can these dice been rolled? Well, I can just go ahead and count the sides. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and there's 6 this way too. So 6 times 6 is 36, and both of those can be divided by 9, so it reduces to 1 over 4, which makes letter C my answer. Here's our last example. Instead of having sick time, Klein Manufacturing offers personal time to their employees. An employee can have up to 5 days of personal time a year before they start using their vacation time for illness. Any unused personal time is treated as vacation time for the following year. Employee records over the past year are presented below. Personal time taken in days, and then we have 0 through 5, and then the number of employees that did each of those. So if an employee is selected at random, what is the probability that over the past year, the employee took 3 personal days? So here we had to find out how many total number of employees there are. So that means we're going to have to add all of these up. So if I go ahead and add 3 plus 4 plus 3 plus 4 plus 2 plus 2, if I add those all up, that's going to give me 18. So that means I have 18 total employees. And how many of them took exactly 3 personal days? Well, if I look at my chart, I have 4. And each of those numbers can be divisible by 2, so that simplifies to 2/9. So my answer here is A.